Have you or a loved one suffered from anxiety? Do you sit at your job, stressed every day, just waiting for that clock to hit 5? Do you want to feel relaxation and be confident that everything's going to be okay? If any of your answers to those questions were yes, then you may just need some kinetic art. More seriously, I've always been pulled towards mechanical principles and kinetic sculptures that really force you to take a second look to understand how they work. It just tickles my brain in the sort of way that those early 2010s cutting soap videos never could. Of course, that is just the opinion of a smooth-brained engineer. However, looking at channels like Nguyen Thang's and S-Craft, I'm definitely not alone. I want something more than just staring at other people's videos for hours. I want to bring some mesmerizing mechanisms to life through the form of desktop art. This will hopefully not only keep me relaxed and inspired at work, but it'll make for an awesome background decoration and conversation starter that doesn't include asking about the weather. So how do we accomplish this dream? Well, let's set up some requirements and also figure out what mechanism we want to use for our first prototype. First off, the device has to be cool, because what other purpose is there to building something like this if it's not going to draw eyes and make people smile? Next, it has to be quiet, and I mean pin dropping on carpet sort of quiet. I can't have it in the room with me for an extended period of time and also be annoying. Also, I'd love some sort of control over its behavior for stuff like speed and direction. Which brings me to my next point. It has to be structurally reliable. And lastly, the design should be minimal and generally appealing. Nobody wants a huge, clunky, ugly box sitting on their desk taking up a bunch of room. Don't worry, PC, I'm not talking to you. Essentially, I'm building this project in such a way that if I came across it on YouTube, I would want to buy one for myself. With that said, I started diving deep into researching mechanisms, and I had to get pulled out of the video void many hours later.
Oh man, not again. Dang mechanisms. Hey, buddy, wake up.
I came out armed with several dozen ideas, but I think the most fitting one for us to test this concept on just also happens to be one of the most popular models in 3D printing at one point, the glorious bevel gear cube. The way it continuously transitions between stability and chaos while still appearing balanced is so freaking cool to me. I studied up on the mechanism for a bit before jumping into CAD to design my own version. And for those of you wondering, the cube is made up of 8 bevel gears, which are simply just gears that mesh together at an angle. Each gear is attached to the core through a small pin, and in my case also a bearing to reduce friction. It's able to take the shape of a cube because each of the tops of the gears have this extruded section that make it a triangular pyramid of sorts. So to assemble it, all we have to do is pop in these pins and close them in the bearings and slide them into the core. And yeah, I decided to print the gears in glow-in-the-dark filament to bump up the cool factor even more, so it's not only literally shining, but it serves as a very poor nightlight too. Now we have to get the cube to actually move. You may follow the mindset of rotating one of the gears to create the cube's motion, but instead we're going to be holding one of the gears still and rotating the core. That'll make everything rotate around a single point where we can mount a motor. You know, I was initially thinking about some sort of hand crank or coiled up spring to drive the motion of the cube, but the motor just seems like the right choice here for a continuous operation, sort of like those cheap motorized turntables that everyone seemed to use back in the day. But unlike those cheap turntables, we want a bit more power. A pancake style stepper motor, which is just like a normal stepper motor that never hit its growth spurt, will be able to do just that while still staying rather compact. And the simplicity of direct driving the cube's mechanism from the motor shaft makes me confident we can design the project to be sufficiently reliable. Now to actually control the mechanism, we're gonna hook up a power supply, a Pro Micro buck converter, and some buttons for speed and directional input. And this works all right, but I'm not a huge fan of how the buttons feel, so let's use something a little more fitting for the application. This is a linear potentiometer. It simply allows us to vary the resistance between 2 points, showing our microcontroller what to do based on a variable voltage range. If that doesn't make any sense, just know it's like a volume slider for your music. So depending on where the slider is at, we can tell the motor a specific direction and speed to operate with. There is one component that I left out of that list though, which is gonna help determine if we meet that sound requirement. When working with stepper motors like this, you're gonna want a suitable motor driver that helps the microcontroller send amplified control signals like a surprisingly helpful middle manager. While the noise one of these motors produce is dependent on many factors, including part quality, load, and device resonance, it's also heavily reliant on how the stepping control is handled. Many popular drivers use discrete steps. This can cause heavy mechanical vibrations and hence noise. But we're using the TMC 2208 as our driver, which utilizes stealth chop signaling. This kind of current control signal produces a nice smooth sine wave, essentially eliminating our acoustic noise. However, even though our baseline motor sound while I'm holding it is quite low, when I place it on the table, small vibrations get boosted and become quite audible. I tried designing a flexible TPU cover and even applying some foam to mitigate it, but these rubber feet remain undefeated in isolation ability. They also keep the motor from sliding around, which is a huge plus. I tried squeezing all the components together into a small base structure that would sit below or behind the cube, but it ended up being as large as the cube itself, and that's not really the minimal look I was going for. So instead, I developed a split concept design, separating the cube from the rest of the components into a small control unit. They're connected via a single sleeved cable and allow me to hide everything away behind a shelf, below the desk, or even behind my monitors. Not only does this make the motorized cube look surprisingly compact, but it opens up the possibility to use a single control unit to command multiple sculptures at the same time without having to buy multiple microcontrollers and plug in a bunch of power cables should I want to add support for that in the future. And so, with the requirements all met and a solid amount of time spent iterating, I ended up with this prototype. I'm definitely not stopping the project here though, and I can't wait to expand it into a whole library of cool mechanisms. Just imagine being able to fill up a whole shelf of living art, or perhaps gift this to somebody who spends most of their time in a dull office. Although I'm not sure if I'm allowed to actually call this office specifically dull, given we installed a M&M launcher in the last video, but you get what I mean. I'm already working on improving some things like adding support for multiple motors to be driven off of a single control unit, integrating motor header plugs to allow for hot swapping, designing a standardized interface between the motor and the mechanism so you can swap a motor to be used in multiple different sculptures, and even supporting accent lighting should a specific design fit it. However, this thing already looks super sick on my desk, and I find myself regularly looking at it for peace of mind and inspiration. Consider subscribing if you want to see the project move forward, and let me know what you think.